Welcome to you all to the class of Discrete Mathematical Structures. Subject code 18CS36. Today I'll be teaching a topic in Module 1, Fundamentals of Logic. The topic name is Rules of Inference. Myself, Dr. Madhura, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology, Bengaluru. Rules of inference. Consider a set of propositions P1, P2, P3, etc. up to Pn, and consider the proposition Q. Then a compound proposition of the form P1 and P2 and P3, etc. up to Pn, conditional Q is called an argument. The compound proposition which is of the form P1 and P2 and P3 etc. and Pn, implication Q is called an argument. Here P1, P2, P3 etc. are called premises and Q is called the conclusion of the argument. Usually we write the above argument as P1, P2, P3 etc. up to Pn. So therefore Q. So P1 is happening and P2 and P3 etc. up to and Pn. This gives us the resultant as Q. That is why Q is called the conclusion of the argument. This argument is said to be valid if each of P1, P2, P3 etc. up to Pn are true, then the conclusion Q is also true. So we have an argument to be a valid argument if each of the P1, P2, P3 up to etc. up to Pn are true, then conclusion is also said to be true. That is, the argument P1 and P2 and P3 etc. up to Pn, conditional Q is valid only when P1, P2, P3, P1 and P2 and P3 etc. up to Pn implies Q. Conclusion should give us as an implication. Note, in an argument, the premises are always taken to be true. That is P1, P2, P3 etc. up to Pn are always considered to be true. Whereas the conclusion may be true or false. The conclusion is true only in case of a valid argument. So suppose we have a valid argument, then the conclusion is assumed to be true. Otherwise, the conclusion is false. The premises is always considered to be true. That is P1, P2, P3, etc. up to Pn is always assumed to be true. The conclusion may be true or may not be true. The argument P1 and P2 and P3, etc. up to Pn, implication Q is a tautology for valid argument. So suppose the argument is valid, then the argument which is of the form P1 and P2 and P3 etc. up to Pn conditional Q is a tautology. Means the truth value is true. Some of the rules of inference are as follows. First one, rule of conjunctive simplification. For any two propositions P and Q, if P and Q is true, then P is true. Suppose we have two propositions P and Q. If we have P and Q to be true, then this can conclude P to be true. This is symbolically written as P and Q implies P. Second one, rule of disjunctive amplification. For any two propositions P and Q, if P is true, then P or Q is true. That is, symbolically, P implies P or Q. Third one, rule of syllogism. For any three propositions P, Q, and R, if P implication Q is true and Q implication R is true, then P implication R is true. So rule of syllogism can be applied for the three propositions P, Q, R. And suppose we have P conditional Q to be true and Q conditional R to be true, then this implies P conditional R is also true. Symbolically, P implication Q and Q implication R implies us P implication R. The same thing can also be written in the tabular form. So we can have P conditional Q as one of the premises, Q conditional R to be another premises, and therefore conclusion will be P conditional R. So there should be an AND between all the premises. So P1 and P2 etc. up to Pn. So that is why there is an AND between these two premises. Next we have rule of modus ponens. If P is true and P conditional Q is true, then Q is true. The modus ponens rule says that suppose we have two propositions P and Q and we have P to be true. P is one of the premises which is true. P conditional Q is also true. Then Q must be true. Recalling the definition for conditional or the implication, only when we have 1, 0, the resultant will be 0. So we have P to be already true. So P conditional Q is also true. So resultant of this is also 1 already. So that is why Q also must be true. Symbolically, this can be written as P and P conditional Q implies Q. In the same tabular form, we can write down P is one of the premises, P conditional Q is another premises, and the conclusion is Q. So therefore, Q we can write down. Next we have rule of modus tollens. If P conditional Q is true and Q is false, then P is false. We have two propositions P and Q, and suppose P conditional Q is true and Q is false. So Q is already assigned a truth value 0, then P is also false. So we have P as a false expression because P conditional Q is true. Next, the same thing can be symbolically written as P conditional Q and negation Q implies negation P. Because we are taking Q and P as false here, the same is expressed here as negation Q. Remember from the theory, each of the premises is assumed to be true. So Q is false is a true statement. So negation Q will be a truth statement. So P is false is the conclusion. So this is symbolically negation P to be true. The same thing in tabular column, we can represent it as P conditional Q is one of the premises, negation Q is another premises, and hence the conclusion is negation P. Next we have rule of disjunctive syllogism. If P or Q is true and P is false, then Q is true. Rule of disjunctive syllogism is also applicable for two propositions P and Q. Suppose we have P or Q is true and P is a false expression, then Q is true. Symbolically, this is represented P or Q is one of the premises and there is an AND between it. P is false, so negation P is true. That is why we have taken negation P, and this implies Q for us. Because Q is true, this is therefore giving us conclusion as Q. In tabular form, this can be written as P or Q, which is one of the premises. Negation P is true, so this is another premises. Conclusion is therefore Q. Seventh one, rule of rule of contradiction. If negation P conditional F naught is false, then P is true. Negation P conditional F naught is false. So F naught is always having a truth value 0, and this conditional is giving me 0 as a false expression. So it should be 1, 0, then only resultant of the conditional is 0. So negation P has to be false, and that is why P is true. So symbolically, this is written as negation P conditional F naught implies P for S. So these are the 7 rules of inference using which we have to do problems. So all these rules has to be memorized. And when we are applying problems or working problems on rules of inference, it is also an application of laws of logic. So we will be sometimes using some of the laws what we learned in the previous class. So we will do problems on rules of inference. Problems. First question. So I will take up some of the statement questions first. First question. If Ravi goes out with friends, if Ravi goes out with friends, he will not study. Put a comma. He will not study. This is one of the premises or an argument for us. If Ravi does not study, if Ravi does not study, his father becomes angry. His father becomes angry is another statement for us. Third statement, his father is not angry. His father is not angry. Therefore, you can put a line and write down, therefore, Ravi has not gone out with friends. Ravi has not gone out with friends. So we have to prove whether this is a valid argument or not. So let us see the solution for the same. We will be first assuming the prepositions P, Q, R, etc. according to the data. So suppose let us assume the first statement says Ravi goes out with friends. So let us assume that to be the preposition P. We have Ravi about his studies. Ravi studies or whether he does not study, right? We can assume one of the preposition in terms of the study. Then thirdly, his father gets angry. Ravi's father gets angry can be assumed to be another preposition. So based on these prepositions, we will be able to write down the given argument in the form symbolically or the tabular form of it. So let us one by one do that. Let P be assumed as Ravi goes out with friends. Ravi goes out with friends. Then let us assume Q as another preposition. Ravi does not study. Ravi does not study. Then R be the preposition denoted by his father gets angry. His father gets angry. Therefore, the given argument reads, that can be rewritten in this form. First sentence says that if Ravi goes out with friends, he will not study. That is P conditional Q. Ravi goes out with his friends is denoted by P. Ravi does not study is the proposition denoted by Q. So first one is of the form if then. Then is obvious, they need not give it in the question. So it is of the form if then. So we have to write down in the form of a conditional. So first one reads the statement as P conditional Q. P conditional Q. Second one, if Ravi does not study, that is Q conditional because we have if then, his father becomes angry. We have denoted his father becoming angry as the preposition are. So that can be written as Q conditional are. Q conditional are. Thirdly, his father is not angry. We have taken his father gets angry as the proposition are, but this is not angry, so represents negation are. Negation are. We have the conclusion also given, and we need to check whether it is a or valid argument or not. So Ravi has not gone out with friends. Ravi has not gone out with friends. Ravi going out with his friends we have taken as a proposition P. He has not gone out with his friends can be written as negation P. Negation P. So this is the argument given for us in the form of a tabular column, tabular form we have written it. Now taking and between these propositions, that is P conditional Q and Q conditional R and negation R. This should imply as negation P. If we get the answer as negation P, then the given argument is a valid argument. Otherwise, it is an invalid argument. So in the question, we can just put a word that test whether the following statements are valid or not. So I'll just put a word here in the heading, test whether the following are valid. We have to check or verify whether the given statements are valid or not. Okay, so let us write down the tabular form in the form of and. Each one of these are premises for us. P conditional Q is one of the premises. Q conditional R is another premises. Negation R is another premises. We have to check whether the conclusion is negation P or not. If we arrive at negation P as the conclusion, then the given argument is a valid one. Otherwise, it is an invalid argument. So we'll just consider the same thing now. Consider P conditional Q and Q conditional R and negation R. Between each of the premises, we have to consider and between them. So what is the first two gives us P conditional Q and Q conditional R. By the rule of syllogism, we can write down P conditional Q and Q conditional R as P conditional R. So this implies for us P conditional R. I will write down and R and negation R as it is. And we have here we have used the condition. We have used the rule of syllogism. Rule of syllogism. Applying rule of syllogism, we have got this. And this is actually combining these two expressions, that is P conditional Q and Q conditional R. Combining these two, applying the rule of syllogism, we have obtained P conditional R and negation R. Now what is the next step? Next step, we can apply rule of modus tollens and we can conclude or we can arrive at negation P. So this implies for us negation P by applying the rule of modus tollens. We will recall the rule of modus tollens. First I will write down the reason. Rule of modus tollens. So rule of modus tollens says that P conditional Q and negation Q implies negation P. P conditional Q and negation Q implies negation P. Instead of Q here, we have R as the proposition, that's all. So P conditional R and negation R using rule of modus tollens, this is negation P. So therefore, we have arrived at the requirement which is negation P. That is why we can conclude the given argument is valid. I'll just write on the conclusion. Thus, the given argument is valid. Now we will see second problem. Second question. Second question says that I will get grade A in this course. I will get grade A in this course. I will get grade A in this course, or I will not graduate, or I will not graduate. This is one of the statement. If I do not graduate, if I do not graduate, comma, I will join the army. I will join the army. Third statement, I got grade A. I got grade A. Can put a line and conclude. Therefore, I will not join the army. I will not join the army. So this is the given statement for us, given argument for us. We have to check whether this is a valid argument or an invalid argument. If we are able to arrive at the conclusion what we have here, then it is a valid argument. Otherwise, it becomes an invalid argument. So very firstly, we need to denote each one of these expressions in the form of the propositions. So I have one of the expressions saying that I will get grade A. So regarding about getting grade A, I can denote one of the propositions A P. I will not graduate. So I will not graduate can be taken as another proposition, say Q, based on getting graduated. Third one, joining army. So regarding joining army, you can take it as another proposition. So like that, we will denote each of the propositions and write down the symbolical form of it and check whether this is a valid argument or not. So solution. So very firstly, I denote P by, let P be, I get grade A in this course. I get grade A in this course. I get grade A in this course. I denote by the proposition P. Next, let me call Q as I do not graduate. I do not graduate. And thirdly, R I will denote by I join the army. I join the army. So regarding getting grade A in the course is one of the proposition. Regarding getting graduated is another proposition, and joining the army is the third proposition I have denoted. See, it is not a compulsion that you have to call Q as I do not graduate. You can denote it by I graduate, and later while writing here in the symbolic form, it should be negation Q. That's all. Okay. So it is not a compulsion. Based on how you have assumed the propositions, accordingly you will write down these statements and try to get it is as a valid statement. If not possible, then it is a invalid argument. Now the given argument reads, the given argument reads, we will write it down symbolically. So first one is P or Q. I will get grade A in this course. I will get grade A in this course is P. There is a or in the middle. I will not graduate. I will not graduate is Q. So first statement reads P or Q. P or Q. Second one, if I do not graduate, I will join the army. So it is of the form if then. So implication symbol should come. If I do not graduate, Q conditional R. Joining army is nothing but R. So second one, we read it in the form Q conditional R. Q conditional R. Third one, I got grade A. So getting grade A is nothing but P. P. Therefore, the conclusion is I will not join the army. Joining army is R. I will not join the army means negation R we have to write down. Negation R. So now we will check whether this is a valid argument or not. Between each of these premises, we have to consider and we have to try to arrive at negation R. If we arrive at negation R, given argument is valid, otherwise it is invalid. So between each of the premises, we will take and proceed now. Consider P or Q and Q conditional R and P. And P. Now we will use P or Q in the conditional format. Okay, we can write it down P or Q as negation P, conditional Q. Negation P, conditional Q. So this is logically equivalent to writing negation P, conditional Q. Remaining I am writing as it is Q conditional R and P. I have written as it is. Now what did we actually use here? I will write it down as a reason quoting for you. So we use the expression for P conditional Q. Recall the property. P conditional Q is always logically equivalent to negation P or Q. P conditional Q is always logically equivalent to negation P or Q. We had it in the form of or, we used the other way. That is in the form of conditional, we wrote the expression. Right. So this is now using rule of syllogism. I can combine these two, negation P conditional Q and Q conditional R. Can be written as negation P conditional R and P I will write down as it is. So this is using which rule? We have applied rule of syllogism. We combined these two and applied rule of syllogism. Rule of syllogism. Now we again use another rule and try to obtain the required resultant. We have, before applying another rule, we again remove this conditional. Using the same expression P conditional Q can be written as negation P or Q. So we will use it again, once again, and write down the or form of this. So this can be written as P or R. So this is nothing but logically equivalent to P or R. P or R and P. P or R and P. So again I applied the formula P conditional Q is logically equivalent to negation P or Q. Negation P or Q. Next, now we will apply and between these two. So we have and between these two, no? So it is rule of conjunctive simplification. The very first rule what we learned, that is P and Q can be written as, or this implies just P. So P and Q implies P for us. So this is implies P or R for us. P or R for us. And which rule we have applied? The first rule, rule of conjunctive simplification. Rule of conjunctive simplification. Right. So we have arrived at P or R. P or R means it is not possible to represent P or R as simply negation R. Our conclusion has to be negation R. But since we have arrived at P or R, from P or R, nowhere we can arrive at negation R. So that is the reason we can just conclude this does not imply negation R for us. Does not imply negation R for us. So we were not able to apply any of the rules or using some of the laws of logic also. We were not able to arrive at negation R. So the conclusion is given argument is not valid. Thus, given argument is not valid. We'll see the third problem now. Third one. If I study, I will not fail in the examination. I will not fail in the examination is one of the statement given for us. If I do not watch TV in the evenings, if I do not watch TV in the evenings, if I do not watch TV in the evenings, I will study. I will study. This is second statement. Third one, I failed in the examination. I failed in the examination. Therefore, it is given, I must have watched TV in the evenings. I must have watched TV in the evenings. So this is the given argument for us. We have to check whether this is a valid argument or not. So one of the statements is about study. So if I study, we have. So let us assume one of the proposition regarding studying. Failing in the examination can be assumed to be another proposition, say Q. Regarding watching TV, we can assume another proposition. So watching TV in the evenings can be assumed to be the proposition R. So based on these, we shall be able to write down the conclusion and check whether this is a valid argument. So let us write down solution. Let P be assumed as I study. Q, let us assume Q as I fail in the examination. I fail in the examination. Let us assume R, another proposition, as I watch TV in the evenings. I watch TV in the evenings. So let us rewrite this argument now. Then the given argument, reads, let us rewrite this in the form symbolically, in the form of a tabular format. So first sentence is that if I study, if then form, so it is a conditional. I will not fail in the examination. I have taken failing in the examination as Q. So not failing means negation Q. So first one is P conditional negation Q. P conditional negation Q. Second sentence is, if I do not watch TV in the evenings, I will study. Again, this is a conditional statement, if then. So I do not watch TV in the evenings. I do not watch TV in the evenings will be negation R, conditional P. I will study is nothing but P. So negation R, conditional P is the second statement. Third one, I failed in the examination is nothing but Q. Q. And the conclusion is given as, I must have watched TV in the evenings. Watching TV in the evenings is R. So conclusion should be R. R. So let us take AND between these premises and try to arrive at R. If we arrive at R, then it is a valid argument. Otherwise, it is an invalid argument. So let us consider P conditional negation Q and negation R conditional P and Q. Using the contrapositive concept, recall contrapositive, P conditional negation Q can be written as Q conditional negation P. That is the contrapositive of the first term, that is P conditional negation Q. So I will write down the contrapositive of the first term as well as the second bracket. The contrapositive of negation R conditional P is nothing but negation P conditional R. So we use contrapositive for both these bracket terms, and this can be written as logically equivalent to Q conditional negation P and negation P conditional R and Q as it is. Q conditional negation P and negation P conditional R and Q. So using contrapositive. So I'll just write down the contrapositive of any implication for you. So using contrapositive, we have obtained this. That is P conditional Q is logically equivalent to negation Q conditional negation P. This is the contrapositive what we have learned in the previous topic. So using contrapositive, we arrived at this expression. Now, what is the use of applying contrapositive? Is observe it is of the form Q conditional negation P and negation P conditional R. So clubbing these two, I can apply the rule of syllogism and combine these two expressions together and write it down as, so this implies for us Q conditional R and Q write down as it is. So this is an application of rule of syllogism. So we clubbed these two and applied rule of syllogism. Rule of syllogism. Now we apply another rule to obtain or arrive at the required answer. This is of the form P conditional Q and P. P conditional Q and P gives us just P, or here it is just R for us. P conditional Q and P gives us Q for us. So this is applying rule of modus pons. So this implies for us just R. R. And which rule have we applied? I will just mention it to you. We applied rule of modus pons. Rule of modus pons. So that is nothing but P conditional Q, rule of modus pons I am writing, P conditional Q and P implies for us Q. Implies Q for us. So we have arrived at the required conclusion. No, our conclusion was R, and we have arrived at the required conclusion. So we can conclude the given argument is valid. Let us conclude the same thing. Given argument is valid. So that's all about this problem. Okay, next problem. Sometimes the given question need not be a statement problem. It might be symbolically given for us. So next set of problems I would like to consider on symbolically given expressions or the arguments for us. And we have to check whether it is a valid argument or not not a valid argument. Okay, so let us see the fourth question. It is given that negation P or negation Q conditional are and as. Then second statement is are conditional T, and thirdly it is negation T, and conclusion is therefore P. Therefore P. So we have to check whether this is a valid argument or an invalid argument. So very firstly, given each of these premises, we will write it down in the form of and try to arrive at or conclude P. Okay. So solution, we consider negation P or negation Q conditional R and S. This is one of the premises for S. So I will put a big bracket for this, and R conditional T and negation P. This is the given premises, and that is and between them we have considered. So this implies using modus tollens. I can write down R conditional T and negation T as negation R. P conditional Q and negation Q implies negation P for us using the rule of modus tollens. So we will just club this and write down the next step. So this implies for us, first entire bracket I will keep it as it is. So negation P or negation Q conditional R and S, and we arrive at negation R. Negation R. So this is using rule of modus tollens. Rule of modus tollens. It is always preferable to write down the rule whichever you are applying so that we will have a better clarity. So next we will use rule of disjunctive amplification, and we write down negation R as negation R or negation S. We introduce negation S and we use the or symbol between that and apply the rule of disjunctive amplification. We'll recall what is rule of disjunctive amplification. So rule of disjunctive amplification says that P implies P or Q. So I just have P now. I just have the form of P. So I can write down P as P or Q. In place of Q, I am introducing negation S. So this gives me first entire big bracket. I will write on as it is. And the negation R can be now written as negation R or negation S. Negation R or negation S. And this is an application of disjunctive amplification. So we applied the rule of disjunctive amplification. Rule of disjunctive amplification. Now, what was the purpose of applying the rule of disjunctive amplification is, We can consider we have R and S here. So this also, if I arrive taking negation outside applying De Morgan's law, if I arrive at negation of R and S, correct? Later it is an application of modus tollens. Okay, how is that? We will see in the one or two steps. First, I will apply De Morgan's law for this. So since we are applying a law, I will write it down logical equivalence symbol, and we have negation P or negation Q, conditional R and S as it is being written, and taking negation a kind of common, we have R and S, negation of R and S. This is nothing but the application of De Morgan's law for us. So I'll just write down which law we applied. Since we applied a law here, I wrote the symbol that is logical equivalence symbol. Okay, so we applied De Morgan's law. De Morgan's law. Now next, what was the purpose of applying De Morgan's law is, I will just write it symbolically here first. See, I can assume this negation P or negation Q as say capital P. R and S I will assume as say capital Q. Here also I have R and S. There is a negation here outside. So negation Q can be symbolically assumed as. So I have it in the form actually P conditional Q and negation Q format. Negation Q. So this implies for us negation P by rule of modus tollens. So this implies for us negation P. Negation P. So it's an application of rule of modus tollens. So we have to arrive at negation P. P value is this bracket, that is negation P or negation Q is nothing but capital P we have assumed. So I have to now arrive at negation capital P. So negation capital P means negation of negation P or negation Q. So this implies negation of negation P or negation Q. And this formula, whatever we wrote here, is nothing but the application of rule of modus tollens. Modus tollens rule. Now, again we apply De Morgan's law. Again we apply De Morgan's law and write down this expression as P and Q. So this is logically equivalent to P and Q. I wrote the symbol of logical equivalence because it's an application using laws of logic. That is why logical equivalence symbol. If you are using rules of inference formulas, then write down implies symbol. Implies symbol. Otherwise use logical equivalence symbol. So this is an application of De Morgan's law. De Morgan's law. So we arrived at P and Q. P and Q is not our conclusion. Our conclusion is P. So P and Q can be written as P using rule of conjunctive simplification. So using the rule of conjunctive simplification, using the rule of conjunctive simplification, we can write down P and Q as just P. So this implies for us P. That is our argument, because given the premises, we have to take and between them and arrive at conclusion P. We have arrived at P, so given argument is valid. So we will conclude the same thing. Thus, the given argument is valid. Next problem. Given argument reads P conditional Q, S or R conditional negation Q, and the conclusion is S or T. S or T. So we have to check whether the given argument is valid or not. So let us see the solution of the same. Solution. We will take AND between the premises first. So consider P and P conditional Q and S or R and R conditional negation Q. R conditional negation Q. Now we first step, let us use the condition for S or R. We convert this R in the form of conditional using the formula P conditional Q is logically equivalent to negation P or Q. So using that, first we will write down S or R as negation S conditional R. So this is logically equivalent to P and P conditional Q, and this can be written as negation S conditional R. Negation S conditional R and R conditional negation Q I will write down as this. So what was that we applied here? We have applied the formula using the formula P conditional Q is logically equivalent to negation P or Q. It was already in the form of or, I wrote it in the form of conditional now. So negation P or Q can be written as P conditional Q. So negation S conditional R we obtain. Now, on the next step, we can club these two expressions by applying the rule of syllogism. We can club these two and write down negation S conditional, negation S, negation S conditional, negation Q. So this implies for us P and P conditional Q and negation S conditional, negation Q. Negation S conditional, negation Q, and here we have clubbed and obtained applying the rule of syllogism. We have clubbed these two and obtained rule of syllogism has been applied. Rule of syllogism. So next step, what can we write down? What was the main agenda of applying this rule of syllogism is now applying the contrapositive. By applying contrapositive, I can write down negation S conditional negation Q as Q conditional S. Q conditional S. So we have this is logically equivalent to P and P conditional Q, and this can be written as Q conditional S. Negation S conditional negation Q can be written as Q conditional S, and we applied contrapositive here. I'll just write down the same thing. What is the contrapositive? Contrapositive of P conditional Q is negation Q conditional negation P. So same thing we have applied here and obtained this. Now again, what was the purpose of applying contrapositive is, suppose I put a bracket here, correct? I put a bracket here for reference. So suppose there is a bracket here, it is again an application of rule of syllogism. So we apply rule of syllogism and we obtain the next step. So this implies P and P conditional S. P and P conditional S, which is an application of rule of syllogism. Rule of syllogism. So what is P and P conditional S gives us? P and P conditional S gives us simply S. Simply S. So this implies for us S. And which rule have we applied here? Here we have applied rule of modus ponens. So we will just recall what is the rule of modus ponens. First we will write it down. Rule of modus ponens. So rule of modus ponens says that P and P conditional Q implies Q. So we have P and P conditional S implies S. Instead of Q, we have S here. So it's an application of modus ponens. But S is not our conclusion. Our conclusion is S or T. So can we just say S can be implying as S or T? We can say so because we are applying rule of disjunctive amplification. So by applying the rule of disjunctive amplification, by applying the rule of disjunctive amplification, we can arrive S as S or T. What is that rule of disjunctive amplification? P implies P or Q. So if I just have P, P can be implied always as P or Q. So I had just S here. S can be implied as S or any other proposition for this. So S or T I have taken because that is my requirement. So we have arrived at the required conclusion. So we can finally conclude that the given argument is valid. So this is all about problems based on the rules of inference. So if the questions are in the form of statement, we assume the statements as a propositions and we try to write down the same thing in the form of tabular form and apply the rules of inference. Sometimes if need by, we will use some of the laws of logic and try to obtain at the required conclusion. If we arrive at the required conclusion, then the given argument is valid. Otherwise, it is concluded as an invalid argument. Hope these problems have helped you to understand based on rules of inference. Thank you for watching.